This problem says if the pendulum in the previous problem had a period of 24 seconds instead, what is the length, or how tall is the building? So how tall is the building and length in this problem are exactly the same, because if the pendulum was attached from the top of the building down to the bottom, like at Drew Clock Tower, if it was attached from the top all the way down to the bottom, the length at equilibrium is effectively the height of the building. So for this problem, we're just trying to find length, not height, which is something that tripped up a lot of people. So for this, what we have is the fact that we know a couple of things. We know the period, which is 24 seconds, and we know that we're on Earth, so that gravity in this situation is going to end up being 10 meters per second squared, just like normal. So you have period, you have gravity. We're looking for the length, which is going to be how tall the building is in this problem. So the equation that we have to use is the T equals 2 pi times the square root of L over G. That's the problem that we're going to use for this situation. It's a formula, so we're going to plug in all the values that we have into the right spot and go from there. So what you want to do is rearrange this at first. Because we're looking for L, which is underneath the radical, we have to do a lot of different things. So you want to take that period, you're going to divide it by 2 pi, and make sure that you're doing the right division. If you just divide by 2 pi, the calculator won't be happy. So T over 2 pi is equal to square root L over G. Then we need to get rid of the radical. So we're going to square both sides. And when you square both sides, you're going to square the numerator and the denominator. So T squared over the quantity 2 pi squared is equal to L over G. We're trying to solve for L, so we need to multiply both sides by G in order to get rid of it. So you end up with G times quantity T squared over 2 pi L. Alright, now what you could do is rewrite that 2 pi squared as 4 and pi squared, because that squared ends up getting distributed. So you'll see that I do that down here and mess up a little bit. Sorry. So you plug in what you know, 10 for gravity, 24 for period, and then over 4 pi squared equal to length. If you do that, it's without the parentheses. I'm going to fix it in a second so you'll see it. So you end up getting a length value when you solve this problem. It's a very large number because the period of 24 seconds is pretty big, and then it's multiplied by a gravity of 10. So when you go through all this, type it in. Yeah, that should be 4 times pi. The length ends up being 145.9 meters. So that is how tall the building is. That's the length of the pendulum. Designing a pendulum to have a period. Number 2 says you're designing a pendulum to have a period of 1 second. You want to figure out how long it is. So capital T here for period is going to be 1 second. Gravity is still 10 because we're on Earth, and you're solving for length. So the equation that you want to use for this is the same as the previous, 2 pi times the square root L over G. And when you do that, you again have to rearrange for L, which becomes G times T squared over the quantity 2 pi squared. And since we know G and T, plug it all right in for the length. Again, be super careful when you're using the calculator that you type in the 2 pi squared correctly. Right? You don't want to plug it in and then accidentally divide the wrong thing. Alright, so when you type this in the calculator, you end up getting a value of 0.25, and that's in meters. So what that ends up being is about 25 centimeters. So in order to effectively make a pendulum with a period of 1 second, you need 25 centimeters of length to do so. Right, and remember that period and frequency are inversely related. So once you calculate the period, you can use the frequency, which is frequency equals 1 over period, which is the inverse, in order to calculate that value. And you end up getting the value of 3.75 to the negative first, which is 0.27 if you round hertz. Okay, so that is how many oscillations happen per second. So 0.27. Is that okay?